So this is problem 3.6, and this is just one of the static equilibrium problems. So I've already set it up in the given, find, and solution format. Basically, the problem statement is that the gusset plate is subjected to the forces of three members. Determine the tension force in member C and its angle theta for equilibrium. The forces are concurrent at point zero. So that just means they go through point zero. Take F equal to 8 kilonewtons. So you see I provided everything that was given and included that forces are concurrent at zero. So it's important to know they go through zero. Um, and then they want us to find T and theta. So I wrote that down. And then we'll get into the solution. So the first thing you want to do with these problems is just draw your free body diagram. So I'm going to start with that. So draw my X and Y axis. Then I'm going to draw my forces. So we've got the F that's in this direction. We have that 9 kilonewton force that goes straight up in the same direction as Y. And then we have this T that goes down in this direction. So that's F. This is 9 kilonewtons. They didn't give us a letter for that one. This one's T. F equals 8 kilonewtons. They give us something about the direction of F. So it's one of those common triangles, so 3, 4, 5. So I'll write that on there. And then they also tell us what theta is the angle between F and T. Because we know that common triangle, 3, 4, 5, we can find out what that angle is just from the x-axis, which might be helpful. So that would be this angle right here. So we'll maybe call that phi. And let's go ahead and figure that out, just so we figure out everything that we can just looking at the free body diagram. So we know we could do tangent or sine or cosine. It doesn't really matter. So let's say we do cosine. I'm just randomly picking one. So cosine of phi equals cosines of SOHCAHTOA, TOA. Cosine is adjacent, so that would be that 4 over the hypotenuse, so 4 over 5. So phi is just going to equal the inverse cosine of that 4 over 5. And so phi equals, so I'm going to use my calculator. 4 over 5 is 0.8, and then I'm going to do the inverse cosine. So phi equals 36.87 degrees. So I'm going to write that into my thing, 36, or into my free body diagram, 36.87 degrees. We also, so what we're going to do with this problem is we're going to start with that really basic equation. So sum of the forces equals mass times acceleration. This is static equilibrium. So it tells us that we want to find the tension force in member C and its angle for equilibrium. So that's why we know it's an equilibrium. So that last term, that acceleration is just zero. So sum of the forces equals zero. And then we can break that down into the sum of the forces in the x direction equals zero and the sum of the forces in the y direction equals zero. So what we'll need to be able to do is we'll need to figure out for t what the x and y components of t are. And right now on our free body diagram we have theta, we have phi, but we're going to also need another angle. So I'm just going to name this, I don't know, alpha. And so we know some about how these equations or these angles are related, right? So we know that theta is going to equal that phi plus gamma. I think I said alpha, but plus gamma. I wrote gamma, so we'll use that. So we know that theta is going to equal, because we found out what phi is, that 36.87 degrees plus that gamma. So that'll be helpful for us later because we are really interested in finding that that actual theta is what they'd asked for. So now we've got everything in our free body diagram, and we'll just need to start with both of these two equations with all our forces and sort of work through those. I'm going to take this free body diagram over to the next page. It's one of the nice things about using the iPad. It makes it a little bit easier to just copy and paste it. Although if you're writing on paper, you can just look at the other page also. So I'm just going to put that over here. So we're going to start with some of the forces in we can either do X or Y direction. Let's just start with the X direction. Some of the forces in the X direction equals 0. So the sum of the forces in the X direction, we'll start and just make sure we hit all of the forces. So we have that 9 kilonewton force. That one's all in the Y direction, so that doesn't have anything in the X direction. Then we have that 8 kilonewton force. That does have something in the X direction. It's pointing to the left, so it's going to be negative because we have X, positive X going to the right, so it's going to be negative. And then it's going to be that 8 kilonewtons. And then we can use those common triangles times 4 over the 5. Alternatively, we could just do that it equals 8 kilonewtons times the cosine of 36.87 degrees. But what we figured out earlier was cosine of that angle of 36.87 degrees equals 4 over 5. So that's how that common triangles thing works, if you're just curious about it. So now we've got the X component of that F force, and then we also need that X component of that T force. And so the X component of the T force is in the positive direction because it's pointing to the right. So plus T, and then times the cosine of that gamma. Because so katoa, cosine adjacent, and so it's that adjacent piece. So that'll give us this X component right here. That'll be that T sub X. I'm going to erase that just because it's a little making our free body diagram a little messy. And then we know that equals 0 because now we started with a 9 kilonewton force, we went to the 8 kilonewton force, and then we did the T force and got all the X components. So I'm just going to reduce this down just a little bit. So we can keep the T cosine phi on one side, that equals, and move that 8 times 4 divided by 5. So that's 6.4 because I'm moving it over to the right side. So we could just say T equals 6.4 over cosine of that phi. So we've got two unknowns in that equation. Fortunately, we have two equations, right? So we had said we have two equations. We have the sum of forces at X equals 0. We also can do the sum of the forces in the Y direction equal to 0. So that's our other equation. And that one will also have two unknowns, so we should be good and should be able to solve it. So now we'll do the same thing where we go through each of the forces. So we're going to start with that 9 kilonewton force. So that 9 kilonewton force is just positive 9 kilonewtons, right? Because it's pointed up. And then the force, the F force, that Y component is pointed down, so it'll be negative. And it's that 8 kilonewtons times 3 over 5. Alternatively, you could do 8 kilonewtons times sine of that angle. And then so that's the second one, and then we need to also get the T, right? So now, and this one's also pointed down, so it's going to be negative T, and then this will be sine of that gamma. So the sine of gamma will give us that Y component of that T, and we know that equals 0. So let's just reduce this down some. So we have 9 minus 8 times 3 over 5. Just entering that into the calculator. 8 times 3, 5 divided by minus, that gives us 4.2 equals T sine of gamma. So now we've got basically two equations. So here's one, here's two. We did do all of the three forces when we did both of those. That's where you can sometimes make a mistake. Now what we can do is we can just substitute 1 into 2. So 2 is 4.2 kilonewtons times T, or equals T, which I'm just going to put in that 6.4 over cosine of gamma times the sine of gamma. And now, because we know trig stuff, so we know, and if you don't know this stuff, then you just want to look it up, but sine over cosine equals tangent. So we're just going to rearrange this and put the numbers all on one side. So we get 4.2 kilonewtons. Let's see, that 6.4 is kilonewtons also. Divided by 6.4 kilonewtons equals that sine of gamma over cosine of gamma, which that equals tangent of gamma. So now we can figure out what gamma is. So we just do that 4.2 divided by 6.4, and then take the arctan, and we get gamma equal to 33.27 degrees. So cool. So now we have this angle. You remember on the previous page, we figured out what the relationship between theta and that gamma was. So it's right here, theta equals 36.87 plus gamma. So let's just take that over. Then we can figure out what theta is. So theta equals that. So now we have theta equals 36.87 degrees plus 33.27 degrees. So theta equals, just entering it into my calculator, equals 70.14 degrees. So that was one of the things they wanted us to find. And then the other thing, now that we have, since we figured out, we sort of jumped ahead a little bit, we figured out what this gamma is, right? We can now plug that back into that first equation. And that first equation was T equals 6.4 over cosine of that gamma. So that equals 6.4 over cosine of 33.27 degrees. So T equals, just entering in my calculator, T equals 7.65, and that's kilonewtons. So what I would normally do now, so we have, I'm just going to highlight the two answers so it's easy to see. Sometimes people will just write it down in the corner, which is fine. Go over here. So make sure we did what they asked us to find T and theta. So we did that. I'm just going to check mark there. 1 out of 2 pages. If we wanted to be really neat for our homework, we would take this and have a header on the second page also. If I could copy it. You'd write it again. Let's see. Didn't give a whole lot of room for it. Actually, sorry, I should have put it in there in the beginning, but I'll go ahead and I'm just going to shrink this down just a little bit so we have space for it. You still see good. Go back over here, grab it again. Copy. Paste it. So now we have this. It's problem 3.6, and this is actually, the right-hand corner is just the page, so page 2 of 2. And there's our answer. So that's it.